All right, so this video is covering angle relationships that we talked about in our last video, but we're going to be using those angle relationships to write equations and solve them. This is on page 8 of your yellow packet. So at first, they want us to name two adjacent angles to angle HOI. So HOI is this angle. And remember, adjacent means that they have to be a neighbor. They have to share one of these rays or one of these walls with HOI. So one adjacent angle could be IOJ because they share this ray right here, IO. So angle IOJ would be considered adjacent. I could also pick HMO, so this angle right here, because they share this ray, ray OH. So angle HOM would also be considered adjacent. Now they want to know which angle is complementary to angle MOL. So complementary, we know, means adds to 90 degrees. So MOL is right here. So we want to know which angle combines to make a right angle or 90 degrees with this angle right here, with this piece. And that would be this angle, angle LOK, because these angles together make a full 90-degree angle. So angle LOK. And to calculate how big angle LOK is, we are going to do 90 degrees, take away the 24 that is already there. And so that's going to give us 66 degrees. So 66 degrees is the measure of LOK. All right, the last part is asking MOH. So let's see, what color have I not used yet? Oh, perfect, green. So MOH and KOJ are what type of angles? Well, they are diagonally across from each other. So angles that are diagonally across from each other are called vertical angles. So they are vertical angles. Therefore, their angle measures are equal. Or we could use the word congruent. So two vertical angles are always congruent or equal. So to find the value of x, we want to use this equation right here, 3x plus 15. So 3x plus 15 has to be equal to the opposing angle. Let's do it in red. The opposing angle, which is 90 degrees. So that's the equation that we can set up and solve for x. So I like to draw my line down the middle, and I'm trying to isolate or get x by itself using inverse operations. Inverse operations are opposite operations. So I have to get rid of plus 15 by doing minus 15. That cancels that out. So I get 3x equals 75. Divide both sides by 3 to undo the multiplication. And I get x is 25. So the big idea here was, since these two angles were congruent, because they were vertical, I could set up the equation 3x plus 15 equals the right angle 90 degrees. And then once I solved it, I got my value of x. So let's try setting up a few more equations. So here, they want us to find the measure of angle ADC. So ADC is right here. And I can see that ADC is vertical to this angle. So these two angles are vertical angles because they're diagonal opposites. What I can also see is that this angle is supplementary to this angle because they make a straight line. That wasn't a great straight line. They make a straight line together. And we know that straight lines are supplementary, meaning they add to 180 degrees. So this person, since they were supplementary, said, okay, well, let's take this angle, 2x plus 1, and let's add it to this angle, x minus 7. And since they're supplementary, they should add up to 180 degrees. So that's where this entire equation comes from. So now they want us to solve for x in this equation, and they want us to explain the steps. So the first thing they did was they combined their like terms. So step 1 was to combine like terms. So 2x and 1x, remember there's an invisible 1 there, make 3x. 1 and negative 7 make negative 6. Then they need to get rid of the negative 6 by doing an inverse operation. So they added 6 to both sides. Then they had to get rid of the 3, so they divided both sides by 3 to get their answer that x equals 62. So on the next page, page 10, they say, how do we know that they are supplementary? How did we know CDE and EDF were supplementary? And we knew because they formed a straight line. And I'm just going to do ST for straight. How do I know that the measures add to 180? Because that's the definition of supplementary angles. So the definition told us that supplementary angles add to 180. Just going to do the angle symbol. Okay, we did solve it. And so now that we know x equals 62, they want us to find angle CDE. And so angle CDE is 2x plus 1. That's what they told us over here. But now I know what x is. I know that x is 62. So I'm going to plug 62 in for x. So 2 times 62 plus 1 is 124 plus 1, which is 125 degrees. So that's CDE. Now let's do EDF. And so EDF was x minus 7. So instead of x, we know x is 62. Oh, that was not the highlighter. X is 62, also not the highlighter. We're going to plug 62 in for x to the expression x minus 7. So 62 minus 7 is 55 degrees. And that's great because these two add up to 180 degrees. So that makes us happy because they're supplementary. So angle ADC, which we talked about originally, is vertical to EDF. So ADC is also 55 degrees because it's vertical to angle EDF. So what facts about angles can we use to find unknown measures? Well, one fact that we can use is that supplementary angles add to 180. That's one rule that we used that helped us set up that equation. Another rule that we used on the last page is complementary angles add to 90. And the last one we use is vertical angles, like EDF and ADC, are equal. So these three things are going to help us set up an equation. So the last question here is asking us to find the measure of ACB or sorry, it's asking us to find DCB. So DCB is this angle. And it's asking us to find the measure of ECD, this angle. So which fact do we want to use to set up our equations based off of the expressions we're given? Well, 3x plus 5 and x plus 11 form a straight line. So we know they're supplementary. So let's write an equation, 3x plus 5 plus x plus 11. Since they're supplementary, add to 180. Let's combine our like terms. So 3x plus 1x is 4x. 5 plus 11 is 16. Let's now subtract 16 from both sides. That gives us 4x equals 164. Divide both sides by 4. 164 divided by 4 is 41. So now we need to find both angles. So let's find this angle by plugging in 41 for x. So 3 times 41 plus 5. 3 times 41 is 123, plus 5 is 128 degrees. And if we find this angle, we do 41 plus 11. So I'm just replacing x with 41. 41 plus 11 is 62 degrees. Ooh, sorry, 52 degrees. So that's this angle. And are those supplementary? Do they add up to 180? They do. That makes me happy. And then DCB, so the red angle is vertical to the one we just found, which was 128. And ECD, the blue angle, is vertical to the other angle we just found, which is 52 degrees. So that's how we use angle relationships to set up equations to find the missing value of x and to find the measure of missing angles in a diagram.